Okay, so let's see for the next example. We are having ln x. Okay, maybe you are going to ask, okay, why we are still using the by parts for the ln x since it's just having one function only, right? But actually we'll be having two function in that, which is if you try to look at here, yes, we are having ln x respected to x. But actually we have by referring to the logpad, yes, we are having ln here, right? We are having ln, which is logarithm here. And another one, actually we have another one function, which is 1, constant 1 here. Constant 1 here we are going to represent as a polynomial. Okay, polynomial 1. Okay, so if you try to look at here, we are going to let u is equal to ln, okay, ln x, and dv is equal to 1 dx lah, 1 dx. So you are going to integrate this one. So derive u here respected to x, it will be equal to 1 over x, and here in v will be equal to x. So then the next one, what can you do? You are going to substitute the formula. So u dv, it will be equal to uv minus with a v du. So then the next one, as you know, you'll be having this one, right? So ln x dx, it will be equal to, and uv, it will be what, which is x ln x here minus with integral of v x du here, which is your 1 over x dx. 1 over x dx will be 1 over x dx here. Sorry, I'm gonna have this one. So just arrange it properly. So 1 over x dx, we've got it from here actually. Okay, so then the next one, actually you can simplify this one. Okay, so at the end of it, you just need to integrate here x ln x minus with integral of dx actually. So then the next one, which is at the end of it, you are going to you'll be having x ln x minus with x plus c, and you can just simplify this one. You can have it this way, x and then ln x minus 1 plus with c. So you already got the answer here, right? Already have the answer here. If it does want to simplify the one, just having this one is a normal one. So let's proceed as for question C. As for question C, by looking over there, okay, so I'm gonna have this one. As for question C here, we'll be having x power of 4 and then ln x dx. So this is for the x here for the ln lah. So using the logpad, this is your polynomial and this is your ln. So looking over here, so if you try to use, this is logarithm, right? So using your logpad again, so tengok kita ada logarithm, kita ada polynomial, so we are going to let u is equal to logarithm. Okay, in this case ln x lah. Why? Using the logpad. Siapa sampai dulu? Who's come first? So if you try to look at here, we'll be having u is equal to ln x. Your dv, it will be equal to x power of 4 dx. Here integral, find the integral, and here find your du over dx. Find the v, what you got over there. You already have the answer here. Du will be equal to 1 over x dx, and v will be equal to x power of 5 over 5. And then substitute in the formula, you'll be having this one. Then you are going to have this answer lah. Just try to close the solution, try to redo it again. Sorry, try to redo it again. The next, last one, okay, having some discussion, which is if you try to look at here, okay, that we need to discuss lah, other than the logpad. Okay, so question D, you will be having 2x and then ln 4x minus with 3 respected to x. So we are going to let u is equal to ln 4x minus 3. Your dv, it will be equal to 2x dx. So 2x dx, and then define what is your du here, and define here what is your v, and then you already got the answer here actually. At the end of it, what I want to discuss, okay, you already have your dv, so integrate this one. You'll be having v is equal to x squared, and derive u respected to x, you'll be having 4 over 4x minus 3. Which is, after that, you are going to substitute the formula, which is the formula we'll be having u dv is equal to uv minus v du. What I want to discuss is about this part. Okay, after you've done substitute into the formula, which is you'll be having here x squared and then ln 4x minus 3, and then minus with and then minus with integral of, okay, in this case you will be having x squared, 4x squared, right? So you will be having 4x squared over with 4x minus 3, okay, 4x minus 3 respected to x. So you'll be having this one, right? So then if you try to look at here, you need to integrate this part. What I want to discuss is regarding this integration. As for this one, we're already done. Okay, as for this part, if you try to look at here, how can we integrate this integral? So we cannot integrate directly, since it is a little bit hard for us to integrate directly. So what can we use? Do we need to use substitution? Okay, just try if you can use substitution. Okay, and then the next one, can we use by parts? If you try to look at here, all the functions that we can see from here is a polynomial only. So the last part, actually we are going to use your partial fraction. So we are going to use your partial fraction. Don't worry, we are going to see the next technique, which is integral for partial fraction. But as for this one, if you try to look at here, it is improper partial fraction. So we need to use your long division first. So after you've done your long division, we are going to do your partial fraction. After you've done your partial fraction, so we are going to integrate your partial fraction and your question until you get the answer. Okay, so actually we have the answers here. So if you try to look at here, please try to redo it again by your own. Okay, so then the next one, which is example 2.8, having some example. We are going to discuss a little bit about this example. It is given to you, which is the question already asked you to use by part, so you need to use by part. We are going to integrate x squared e power of 2x respected to x, respected to the x, and then we are going to use your by parts again using your log pad. In this case, we are going to meet with your exponential and with your polynomial. So in this case, we are going to let u is equal to your x squared, because who's come first sequentially using log pad, which is polynomial. So and then dv will be equal to e power of 2x respected to x, and then here we'll be having du respected to derive u here respected to x, so we'll be having 2x. Integrate your dv and integrate e power of 2x respected to x, you will be having e power of 2x over with 2. And then you are going to substitute into the formula, which is uv minus v du. So uv will be having x squared e power of 2x over with 2 minus with v du, which is e power of 2x over 2. And your du here, which is, it will be equal to 2x dx, right? 2x dx. As for this one, you can simplify this part. Okay, so if you try to look at here, we'll be having x squared e power of 2x over with 2 minus with, as for this one, we'll be having e power of 2x x dx. So again, if you try to look at here, how can we integrate this function? Which is, actually we still need to use your by parts. So the second by parts, which is you are going to let again, so look over here, we'll be having polynomial, we'll be having exponential. So again, by using a log pad, who's come first, which is polynomial, and then exponential, right? So the polynomial is coming first, so it will be x here, and your dv will be equal to e power of 2x respected to the x. So find the integral for this one, and derive u, it will be equal to dx. And then here v, it will be equal to e power of 2x over with 2. Substitute into the formula. So before that, yang ini jangan kacau yang tadi ni. So what can you do? Substitute what you have, which is you'll be having what you have just now, which is x squared e power of 2x over with 2 minus with, okay, as for this one, substitute into the formula, which is the formula that you have, the second by parts, so uv minus integral of v du. So this is the new one, the second by parts. This is what I mean, the second by parts you have, which is from this one, okay, from this one. So then the next one, what can you do? Which is you'll be having x squared here, e power of 2x over with 2 minus with, what is your u in this case? U is equal to x. What is your v? Is equal to e power of 2x over with 2 minus with integral of v du. So the v again will be having e power of 2x over 2, and du here, which is your dx. Okay, so then the next one, integrate this one directly, you'll be getting So before that, e power of 2x over 2 here, minus with the x e power of 2x over with 2 here, and minus with, in this one you will be having e power of 2x over with 4. And don't forget we'll be having plus with 2. Actually, we already have the answers here, and if you try to check the answer, already have the answer, which is we have a similar answer. As for this answer, they already simplified for you. Okay, so I hope you are clear about this part. Please make sure you try it again. Okay.